All right, hi everyone.
Hello.
Welcome to our second panel. For this panel, we're very excited to have our panelists join here today. Vanishree from Fermah, David from zkSecurity, and Jen and Lumi, who is formerly part of zkSync, join us here today to discuss about custom circuits and zkVMs. So for some context as to what inspired this panel topic, a couple of months ago, Vanishree sparked a Twitter debate posing the question if custom zk will eventually take over zkVMs when applications mature and when factors like time to market are no longer a concern. So there were some mixed opinions about this. Like on one side, zkVMs are more flexible. They can help enable that lower barrier to market entry, generally ideal for those newer applications, and can also handle some more complex computations. But custom circuits at the same time also have their own advantages in terms of optimization benefits, in terms of performance. So there's really both advantages and also like disadvantages to both ends. But our goal here today is to really try to flesh out the both these advantages and disadvantages to each approach and help everyone in the audience navigate through these trade-offs in choosing like which approach is more suitable depending on what you're looking for, depending on your needs. So each of our panelists here today have been involved in the zk space for many years now and have very many insights to share. And I'm very excited to have this discussion with all of you. All right, so I'm wondering, as like a starting point, I'm wondering if each of you can tell us about your general views about the roles of zkVMs and custom circuits in building zk applications. Based on your experiences, your personal experiences, do you have any preferences to which one, or if there's certain applications where having using zkVMs may be more advantageous to than custom circuits, and also vice versa?
Is there an order in which we should go? Or?
Okay, sure. We can first start off with you, David.
All right. Yeah, I mean, personally, I'm not a really in the building business, so I don't really have a like stake or anything. Actually, we're as the founder of zkSecurity, we're auditing both zkVMs, compilers or programs, and circuits. So from my point of view, it's great to see the sort of diversity and the different approaches and how the technology is growing in different directions. I guess the most interesting aspect for me is the security of these systems. And there it's interesting to see the sort of trade-offs that you're making. And I'm sure we'll talk more about these kind of things. Actually, Vanishree, I was listening to the panel you did recently on this topic, and you guys talked a lot about security. So I'm interested in talking more about that as well. But I would say personally, I don't have a preference. I think zkVMs for users are pretty awesome. Like it clearly make things easier and more practical. And from a simplicity perspective, circuits can be really elegant, and there's also different approaches like abstract zk abstract state machines and these kind of things. They're also very interesting to me. It's all fascinating, and looking forward to hear more. As Vanishree, I said your name, so I have to.
Okay, I'll go next. Alice, good to see you. David, good to see you. Nice to meet you, Lumi. So zkVMs versus custom circuits, do we have a preference? We actually don't have a preference. We at Fermah, or me personally, don't have a preference. We actually are building, at Fermah specifically, we are actually building a universal proof generation layer. We want to be able to generate proofs for any proof system, be it zkVMs, custom circuit-based proof systems. For any proof systems, we want to be able to generate proofs in a cheap and performant manner. That's our goal, and we won't take sides for credible neutrality. There is, now having said that, Now, let's look at the two different goals people can have. One goal is embracing zk, make it easy for me. The other goal is I've embraced zk, make it fast, make me win the world, make me win the competition. These are two different goals. A project will have goal number 1 in the initial stage. A project will have goal number 2 at later stages. For goal number 1, zkVMs are great. For goal number 2, there is room, a very reasonable room for custom circuits. I think one doesn't win over the other. I think it depends on the phase of a project, and even in the tweet and even at various places, I've made it really clear that I actually want zkVMs to win, and I'm a fan of all these zkVM projects, including your own, Alice, to win. It is not to take away the fact that zkVMs are useful. I think zkVMs are probably the way to enable mass adoption of zk by lowering the barrier to entry. There is no taking away. This tweet or this whole discussion is no taking away of the fact. And I think the goal, though, of this discussion is to put boundaries to where zkVMs can be useful. And I think the boundaries is when a project reaches the level of maturity where time to market and engineering costs are not concerns anymore. So
I guess I have a, sorry.
Go ahead, Lumi.
I guess I have a controversial view on this. I do have a preference, right? It depends on the application, right? There is very legitimate use cases for high performance, high throughput applications like client-side proving on your phone. Maybe don't run an entire zkVM on your phone, right? Maybe don't prove an entire zkVM on your phone. There's applications like privacy, which requires client-side proving where like custom circuits really do matter. But I think for the vast majority of applications, zkVMs are really the sort of end game. Now I feel like I'm making a bad joke right now, but the idea is like back in the day before DOS, right? We had, for every single computer architecture you had a different CPU, you had a different GPU, you had to basically write a custom OS, right? Let's call these custom circuits. This is really overgeneralizing a bit, but until Microsoft stole DOS, invented DOS, then you essentially had one operating system that could work for any application running on any computer architecture, as long as it followed certain standards, right? And this made it possible to get that mass adoption. You sort of it's less efficient than writing a custom circuit. It's less efficient than having a custom chip that is specialized on something, but over time, that performance hit that you took by having this sort of general operating system became less and less relevant, right? And I honestly think that at least in the medium run, possibly long run, we're going to start standardizing these systems, right? There's going to be a few of these zkVMs that will be battle tested over time, like RISC-0 or SB1, or we had zkSync. We were developing something called zkOS, which is also a RISC-V based zkOS or zkVM. And honestly, I think that's where you really start scaling into mass market adoption for developers, like being able to develop any Rust program, being able to run any virtual machine on top of a zkVM without really actually having to know anything about zero-knowledge cryptography, without having to worry about constraints, without having to worry about making sort of a simple bug at a circuit level, is what really enables those 100 million JavaScript developers to come in and start developing applications. So it kind of depends on what your goal is. Like if you really need performance, if you really need privacy that isn't just Validium, but the actual zero knowledge of not just the sync property of zero knowledge proofs, then custom circuits make sense. But for the most part, I think we'll move in these ecosystems, like as the senior product manager of zkStack. So Elastic Chain was basically my product, right? Right now we're launching more and more of these general EVM chains, and the sort of future direction of Elastic Chain, and I think Polygon and will be Optimism, will be Arbitrum, will be you write an app. Either you run it on shared server like Arbitrum 1, right? Or you launch it as its own chain, and you don't need to run EVM. Like if you write Uniswap in Rust, why do you need EVM at all, right? You could just run that on a zkVM, and then there's some tricky bits into how you essentially do that safely while interoperating with the rest of the ecosystem that are probably outside of the scope of this panel. But I really do tend to lean on zkVMs for sort of at least the vast majority of applications for developers using this architecture that is zk, at least for the zkSync property.
Yeah, thank you. And also we have Morgan from Lita who just joined us. Morgan, the question that we were discussing about is your general views about the roles of zkVMs and custom circuits in building zk applications, and if you have any preferences based on your personal experiences. So far, Vanishree and David seem to not have any particular preferences. Daniel's more leaning towards the zkVM side, especially in terms of like mass adoption for developers. But curious to hear your thoughts too, Morgan.
Sure, yeah. So I think like when it comes to custom circuits, there's 3 different approaches to keep in mind. There's where you hand roll the circuit yourself, and that's always going to be like an element to some extent in the other approaches. But like then you have the circuit compiler approach where you take some source code and compile that into a circuit. And then there's the approach where you have a zk virtual machine with ISA extensions. And so then with that, you'll have hand-rolled circuits for particular instructions that are like specific to your use case somehow. And so like I think like for most applications for the near term, the VM with ISA extensions is the most practical approach. Occasionally, when you have a particularly simple problem that needs to be highly optimized, then a hand-rolled circuit is the way to go. And I think in the long view, probably circuit compilers are going to be like pretty optimal. But there's a lot of R&D that needs to be done on that to get there.
Yeah, definitely.
Part of the problem with hand-rolling circuits is that you can end up with a really large, messy circuit where it turns out that it would have been more efficient to just use a zkVM or break it down into simpler pieces that you would then build up and move some of the complexity out of your circuit and into your witness.
Yeah, definitely. And thank you for making that, distinguishing all those 3 different kinds of approaches from there, Morgan. And also appreciate you, Vanishree, for specifying that perhaps these approaches will be optimal for depending on the type of goal for the type of stage that a project is in. So like you mentioned, Vanishree, like make it easier for me in that kind of earlier stage. Most likely zkVMs would be better suited. But then when we reach a later stage, and then the question is not just making it easier, but making it faster, making it more performant, then custom circuits will play a role there. So really appreciate that from you, Vanishree. And then also Daniel, really liked the comparison that you made with the DOS days in terms of like custom. We don't see this just within zk, but then also with our general computation as well. And then also David, for you, really appreciate you for making the point about like zkVMs that can make things more easier and practical, but it's also very interesting to see the security of these systems as well and evaluate it on that level. So really appreciate the insights so far from everyone. I'm wondering if we can talk a little bit more about distinguishing the advantages and disadvantages in both zkVMs and also custom circuits. So you guys talked a little bit about this already, but wondering, like, for the audience who may not be familiar with these two types of approaches, if we could make a clear distinction on the key benefits of custom circuits, such as with performance compared to our generalizable zkVMs, and if there's any disadvantages that we need to consider that make zkVMs more advantageous, and then also vice versa with circuits.
Yeah, I guess there's different ways to look at it, but one way to look at it is also like in terms of powers. Like the immediate limitations when you use circuits directly is that you can't really do branching or jumping around or dynamic loops and these kind of things. And so from that perspective, the VM approach is easy. It's more familiar, I guess. Usually you write in a higher level language. People know how to do that. And they don't have to use multiplexers and all sorts of tricks to make the sometimes simple logic work in as a circuit. So yeah, I'd say the main advantage and what the users are really seeing is the simplicity of using a VM. Then there's a performance aspect. I think people here are more qualified than me to talk about the actual performance and if zkVMs are actually slower or they can actually be competitive with circuits, which is an interesting debate as well. And on the security side, I think there's also the notion of like writing circuits directly is pretty hard. It's not for everyone. It requires some expertise and some understanding of this sort of new paradigm of non-deterministic computations. And so we see a lot of bugs when people try to write these kind of circuits. And these bugs can be thought of as inexistent in the VM world. Like it's much harder to write such bugs. In reality, what happens is that you're sort of moving the complexity and you're moving the bugs within the compilers, or most of the bugs within the compilers. So the circuits are still there. The bugs can still be, there, but you're moving them to a different place and creating this nice abstraction for users, which is really interesting, of course, for us. The bugs, we need bugs to to survive. And it's kind of cynical, but of course I want things to be secure, and I wish I didn't have to exist, but this is the state of things. I mean, not, you know what I'm saying. And so yeah, it is interesting from that perspective. Maybe last thing I'll say is that I don't know if you guys have seen that there's arguments previously Lurk Lab that published this blog post recently, and that sort of try to tackle the zkVM or the LLVM approach, and the argument there. I mean, maybe I'm gonna do a bad summary, but the argument there was sort of like we're making things much simpler. We're reusing technology, but by doing that, we're also absorbing a number of bugs and potential bugs and dormant bugs. The stack is becoming quite complicated. And that from a security perspective, that's also fascinating. Lumi, you were saying like we're making things easier for all these, I don't know, JavaScript developers and all these developers. And a question is that should we be doing that when most of these applications are, financial applications? So yeah, I'll leave it at that. For me, these things are fascinating because I'm observing the scene from a security perspective, but I'm very curious what others think about that.
Maybe I can continue on that of like, so from a performance point of view, like just at a higher level example, like let's say that you're writing a program to play Sudoku with your friend, right? You can make a fairly simple circuit on essentially proving to your friend you finished the same exact Sudoku puzzle without giving them the answer because fuck that asshole, he has to do it on his own, right? So you can prove that you beat it first, right? That's a fairly small like program, right? Now the difference in like a zkVM, a generalized zkVM, is now you're proving essentially what RISC has 56 opcodes. Is that right? 50 RISC-V? 54, 56, somewhere in there. Now you have to prove all of that and you have to run this program, right? So like I think it's good to actually take this even at just at the higher level, because it's a fairly understandable problem of like, now you're proving a lot to run a simple program, right? So that's directly from a performance point of view. There's topics about acceleration and other parts that actually sort of are relevant to this, but I think from a high level, it's simple to understand it, right? For the JavaScript developers, of like, if we should be making it simple, it's like, we're sort of bad as humans in abstract concepts of like, we just tend to sort of think linearly. Like when the internet came out, newspapers thought, okay, I'll make a digital newspaper instead, right? And that's my analogy for finance is the first product market fit for especially zero knowledge proof rollups, for example. Like, longer, more complex topic, but essentially we can save billions of dollars per bank if they adopt this technology, right? And that's currently sort of our real use case, but we already see this emerging market of silly games or like, okay, Ponzi dynamics. Again, it's mostly sort of based around financial, but there's also the deeper topic of something like a DAO. It's like, it is financial, right? But it's also a societal organization. Like, how do we collaborate at a large scale? And there are financial aspects to it, the same way that in voting in a normal government affects our finances. But there's going to be a lot built on this technology. And should we enable it? It's to me, coming from the L2 world, is where essentially we're trying to enable all these applications to run with the security of Ethereum, or at least most of the security of Ethereum, right? And I don't want to see more and more projects launch these shitty insecure L1s or launch on less secure L1s. So for me, I think it's really important that we enable not even your average developer, even your like very experienced senior developer, to be able to deploy applications quickly without introducing security issues, without sort of having to learn a whole new field of cryptography or new language, like even a higher level abstraction language. So I do think it's important, and it's going to happen regardless, right? It's just the question is, do we give them an easy path, or do we like gamble on the fact that they'll implement something correctly?
So to David's points, and as well, Daniel, is that your name here? Yeah. So
Lumi.
like
DC keeps selling. I should just say Lumi, so I'm going with it.
Sure. So with the hand rolled circuits, like what you get is like always the potential for better performance. Like if it, you could hand roll like a zkVM if you wanted to, right? If that would be more performant than some other solution. So hand rolled always has the best potential proving, complexity. But the big trade-off there is the harder development costs. I also think that with hand-rolled circuits, you get a somewhat easier verification story, probably, because when you are using a zkVM and a compiler and a program that's running on top of that, then you need to check, okay, does my program verify the statement I'm wanting to prove? Good luck doing that if the program is in JavaScript, by the way. Then you need to verify, is my compiler preserving the semantics of my program? And you need to verify, is this zkVM circuit sound and complete? Whereas if you have a hand-rolled circuit, you just need to verify, does this circuit, verify the statement I want to prove?
But again, everything you just said, we're in an echo chamber. Like, I've been in zk for a long time too. We're in an echo chamber. I even in this like online event, I'm guessing about 95% of what you just said, it's like, I don't want to do that, right? Like, I don't want to even think about it, right? The vast majority of us don't like, assembly is more efficient to write programs in. How many of us actually write things in assembly, right? Like creating a custom circuit, like a physical circuit for doing a specific task is more efficient, but the reality is we buy these little Raspberry Pis for essentially everything. It's not the most optimal solution for it. It's just to me, the question isn't, is it optimal? It's like, what certain use cases actually need like hand-rolled like circuits? That's the bigger question, because over time with hardware acceleration, with having standardization of a couple of these zkVMs, they'll get efficient enough. Like maybe you won't run that directly on your iPhone still, but like for the vast majority, like at least roll-up use cases or the vast majority of applications, it's like, yeah, okay, 1 cent versus like a half a cent, fuck it, And then you do get certain security benefits of you being able to like RISC-0 can formally verify their verifier, and then you sort of inherit that. Of course, there's other, like the compiler alone, there's other security issues that come with that. But I think that's going to be the vast majority of devs, not only in sort of quantity of devs, but also in like economic activity and usage.
There are still people who are writing code in assembly, though, right? People who are building performance critical systems. And now,
right, it's like also
whenever we are, right,
like what language is used to like write the software of, airplanes also, like this kind of a.
But when such applications become wide enough, become valuable enough, more money will go into building tooling to make writing in those languages easier. And such has happened in assembly area too. There are tools that people have built to make it easy to write in assembly easier. You can even handwrite, and then there are tools that can help you make it even more efficient. Or there are also tools that will help you get into the assembly part of the in the evolution of building. You get into the assembly level, and you can tweak it to make it faster. All this is possible. All this humanity has made possible. Why? Because it's important. And my argument is that it'll be similarly important in zk. There will be performance critical systems. So optimize. How much? There are complexity theoretic limits of how much you can optimize. Beyond that, probably it'll be a great question to see. It'll be a great question to research question to think about feasibility of some insanely optimal feasibility. Don't give me construction. Feasibility of insanely optimal zkVMs. We don't know. Right. This is so. There are a few points I want to make. I think analogies only hold till we notice nuances. The analogy with even DOS, right? So with DOS, you want to enable people to write applications where the amount of energy spent or the amount of hardware spent, the difference is very little. And I would argue that for performance critical systems, this differences can become significant. So you want to enable that happening. That is why I think constant obsession about zkVMs should be replaced with obsession with zkVMs while continuing research and development and enhancement of custom circuits tooling. This is one point, and a few other points going back to Alice's original question on what are the advantages and disadvantages of zkVMs versus custom circuits. One disadvantage of zkVMs is that it connects to what Lumi you were saying. There can be simple programs. So to me, simple business logics may not mean simple circuits, right? But simple, like for example, if I want to prove knowledge of exponent, that is super easy. You do a Sigma protocol kind of a proof. That's super, super easy. It may not be business logic wise super simple. However, it can be very, very easy. In that case, you don't want to use zkVMs. Like, if that's all I want to do, I would implore those people to not use zkVMs, right? So simple programs which can have simple constraints expressible in if you're arithmetized, and if they are simple, then you shouldn't use zkVMs. This is an disadvantage of zkVMs in their non-wide applicability. That's one point, and a few other points are. Right now, I think one of you touched upon this, the requirement of having to prove all opcodes. Probably this will change. I think there's some direction going. People are thinking through not having to prove every single opcode. Hopefully we'll reach there, but currently it's a disadvantage, right? And regarding security, I'll give it to you that zkVMs, once proven, will be complete. Once proven, will be sound. Once proven, will be zk. If that's what the aim of zkVM is. However, we are still. So I don't say this as a critique on zkVM itself, but as a critique of current status of zkVMs. We don't have clarity on. We don't have clarity. At least widely educated, at least to a widely educated level, on the level of security that zkVMs offer. And also there is no wide education for developers to assess what is the level of security they want. Do you need knowledge soundness? Do you need a simulation extractability? What intuitive tools are you giving them to say? Do they need simulation extractability or knowledge soundness? We don't know. So to me, soundness of the security of zkVMs, I always until that level of clarity happens, I'll take it with a grain of salt. And advantages of coming to some advantages of custom circuits. I'm clubbing. I think Morgan gave a very good distinction to keep in mind on two ways of achieving custom circuits, either through circuit compilers or hand rolling circuits. So for both those approaches, I think the advantages are that. I gave this example in a podcast earlier. I really like this example because it really gets the point across. The example of Uber becoming so huge across the world. You know how they think about value they create when they're making netted to their product, the way which can reduce the amount of time you need to wait to get your ride. Many people keep staring at your phone until you get matched to a ride, right? Reducing it from, let's say, 30 seconds to 20 seconds. They don't look at 10 seconds. They look at 10 seconds for billions of people. Multiply that. That's the time they're giving back to the world. That's how they think. That's how all products should think. And these are the products where custom circuits will have a place where. Imagine imagine a world where maybe we will have to prove every single opcode. I don't know. Maybe we won't get past that hurdle. Imagine a world, hypothetical world. Imagine that world. Okay, in that world, people then will need to think about custom circuits and reducing those times, squeezing time everywhere possible. So this is very, very necessary for completely democratizing zk, for commoditizing zk. Aren't we aiming for a world where zk becomes the default substrate for computation? And you want that'll happen if you squeeze out in every way possible the cost and time, the cost of proof generation, the time of proof generation. And I think at least as far as I see, and as far as the state of the art is, I don't see zkVMs satisfying that. I see custom circuits satisfying that, and that is why I think they will have a place as far as we can see on how zk can evolve.
That's one of those things of like, I think in a way it's the name is bad. It's not really zkVMs versus custom circuits. It's zkVMs and custom circuits. It kind of depends on like where, like what part of the stack are you using it for? Like if you're using it for the succinct property of building an L2 where anyone can deploy applications, zkVM is probably the way to go. This way you're not choosing the VM and you don't have to run an EVM on a VM or a VM on a VM to run an application, right? There are absolutely like backend, like protocol level use cases where you do need to highly optimize throughput, right? And like this is a good example of like, okay, I don't know how much I can say for Visa, let's say. For them, like people ask like, oh, we have 1 cent transactions, isn't that enough? Like what if we have 1/10 of 1 cent? It's like, no, you need a teeny fraction of that, because for every like order of magnitude, Visa is literally paying hundreds of millions of dollars more. Like for real use cases, you do really need extremely performant, cost effective and fast proving, right? So it just depends on which part of the stack you're at. I think the vast majority of use of zk will likely be on the zkVM level, at least from application developer. But I think probably like the more critical infrastructure pieces, especially outside of blockchain, will probably be custom circuits.
I think with it seems like the narrative is that with precompiles, or I guess with the parts of your zkVM that are hand-rolled circuits, things might get more and more competitive, and the overhead is like being reduced to a point where a lot of applications are becoming realistic. And so that's sort of what you want, right? You want to be able to like prototype fast as a developer. You want to be able to have less and less friction. And as long as the compile times are acceptable and the running time is fine, zkVMs are going to be like an amazing game changer. And but to your point, Vanishree, if you're trying to really optimize things, it's very realistic that some specific applications are going to move back to circuits after they've probably proof of concept something with zkVM, and after they've established a market, and then they need to get really fast. And we see that with assembly, right? Like we have normal code, like we have VS Code written in JavaScript, and then now everybody's trying to write a new thing in Rust. So, and same thing for new cryptographic primitives. People always implement them in whatever language they want, and then you always see assembly implementations of them. So as you understand things more, you always want to go lower down the stack to optimize things if it's feasible. But just on that, it is interesting that we're making zk like more and more approachable. But like another point you mentioned, Vanishree, is like you mentioned that somewhere else. You said we're moving at a breaking-neck pace, which I like the expression. It's very experimental. Like we're a bleeding edge technology, and so the question is still like, we're doing these amazing things for developers, and this is really amazing. But like, what's the maturity of these projects? How many of these projects actually, how many bugs do we have in these projects? How many bugs are going to end up in production? When are we going to have our first $1 million bug in zk? Which we've had a lot of them in Ethereum land, right? So looking forward to that, I guess, to some extent. Of course not, but it is going to happen, and so it's just a matter of time and where is it going to happen. Like it's good to experiment and to research there, But it's also interesting to see how many of these, how many projects have like security teams and really care about making these products not just, usable, but also production ready.
And just emphasizing like Lumi's point on rephrasing the question, it's not one or the other. It's not zkVMs or custom circuits. It should instead be zkVMs and custom circuits, like just depending on the type of use case, the type of application you're going for, and also the priorities as well. If you really want that high optimization or if you want that developer-friendly aspect, it really does depend. And it's something that all of you guys really emphasized on as well. And I'm wondering if we could go into another question on what sort of innovations are needed for zkVMs and custom circuits to better serve developers and end users across a wider range of industries, even maybe those beyond Web3.
Yeah, it's too bad Morgan dropped. I think he would have a good answer there. But it really seems like precompiles are where most of the gains are, and the precompiles are kind of annoying because you can't just use them for free. Like if you want to reuse code that was already written in like Rust or C or like whatever is your high level language, then you're gonna pay the cost of that code and it's gonna be slow. And if you want to replace some parts of it, I don't know, maybe somewhere in the stack there's some elliptic curve arithmetic and you want to replace that with a precompile, it might not be necessarily easy right now. But personally, I'm pretty optimistic. Like when we look at, for example, cryptographic libraries, they let you choose kind of the platform and the optimizations that you want to support, depending on your CPU and the like the CMD instructions that you can support. So I don't see why they wouldn't also offer like a zk backend or like this kind of zk intrinsics, I guess. And so I think that's where we're going to see more development, like libraries that are specifically targeting these precompiles or code that's more available so that you can do that more easily. Maybe something else I can say is that not all zkVMs are equal. There's so many different approaches, right? From the zkVM or the VMs the zkVMs are supporting existing VMs, or the new DSLs or new zkVMs like Cairo and Valida and these kind of projects. There's also like these zk abstract state machines that seem much more simpler in a sense, like what Lurk Lab is doing. And there's the whole let's support beeps or RISC-V or something like that, and let people use LLVM to compile down to these things. So what I like from what I've seen is that the LLVM approach is definitely more user friendly. You let them use whatever language they want. But also, like, again, from a security perspective, like I like it when I see the Cairo guys, formally verifying their VM using Lean. That's like they're going above and beyond to verify the security of what they're doing. So that's really interesting as well. Actually, I think zkSync also is doing some work there, but I don't know.
Yeah.
And zkSync is one of the rare team that has a security team also.
Yeah, good one too. Basic assumption for security should be every system's probably already been attacked and might be under control. That should be your baseline assumption, and then build up from there.
I can go next. So, right, what can we do to further this space in zkVMs and custom circuit world? I guess that's the question, right? I think a zoomed out approach will help in both the cases. in zkVMs, the zoomed out approach could include so one thing that I recently heard, I need to test this for myself. I cannot attest to this, but I heard somebody say that when you're trying to use zkVM, it may not help you get a prover and verifier binary in a few hours. It may take a lot more back and forth. I don't know how true and widely applicable that is. If that is the case, then it is. I think the zkVMs have already contributed a ton in reducing engineering time from months to years. To even if it takes a month, it still is fine. However, and it's okay, I think, for it to take even a month going forward. I wouldn't say that prioritizing reducing that to a few hours is the right priority. However, the priority should be in enabling upgradability. Upgradability is not, we don't tend to talk about this because I think we are either working on a zkVM or we are not working on a zkVM. When we are working on a zkVM, you don't want to enable upgradability into another proof system, right? You want people to be using your own proof system. But upgradability of proof systems is important in zk, and there are multiple things we need to ensure to we need to enable to ensure upgradability. One is standardization on verifier, and that is anyway happening given the fact that we have only certain precompiles on Ethereum, for example, and that is kind of forcing some standardization on what is the verifier that is being used to settle proofs on chain. The other things that we need to make sure to ensure to allow for upgradability are this time developers take to embrace a zkVM. It should be as much as possible reusable. If I spend 1 hour to use to get to use a zkVM1, if I spend 1 month to embrace a zkVM1, I think the work that I do should, as much as possible, be useful. If I think that, okay, let me try also zkVM2, and that work should be reusable. That is something that we should projects should collaboratively figure out and make sure. There are a few other things that I recently gave a talk on the open areas and open problems in the zk
Vanishree,
space.
Can I interject? Because I think
yes.
What you said about upgradability, just to stay on that topic, is really interesting because we haven't really mentioned that before.
Yes.
And it's definitely a plus for zkVMs. Vanishree and I used to be ex-coworkers at Mina, and so that's sort of a subject dear to our hearts because we had that problem of like, we're launching with some proof system, we want to upgrade the proof system, people are going to write zk apps, then how do you update how do you update the proof system without invalidating all of the voiding all of these zk apps? And so if you use a zkVM, the program stays the same, but the proof system can get more performance, and that's definitely a plus in that camp.
Totally. And this is especially true with the breakneck speed at which we are moving, right? A zkVM that is good now, will that be the zkVM that will be good tomorrow? No, likely not, right? And we want, we should aim for a world. We should aim for a world where we are creating the infrastructure in such a way that we are creating the groundwork that'll enshrine the best one at that time to be usable. And for that, you need to enable upgradability. And this is a thesis we hold dear to our heart at Fermah also. Why are we building a universal? So not to shill, but I cannot stay away from what I truly believe. The reason why you want a universal proof generation layer is that the infrastructure that you shouldn't switch from infrastructure to infrastructure as you choose from zkVM to zkVM. There are switching costs. There are pains of different ways, different infrastructure. There are pains of different infrastructure treats you by giving you different kinds of APIs on proof generation time and proof generation costs and the way they ensure. I think that'll all affect. This is why I think a universal proof generation. This is what I think. I think a universal proof generation layer for infrastructure with proof systems and with proof systems enabling upgradability and architectures of applications enabling upgradability. I think this is what we should aim for.
Maybe I can just add on. This is kind of the upgradability. It has to do with security, but this is more focused on proving something to a single source of truth, like an L2, right? One of the nice things of zkVMs is you can run many of these you can run the same computation through many zkVMs and use that to create sort of an easy multi-proof system, right? So you could have, let's say there was 3 zkVMs. This is a lot of redundant calculations, so let's just assume some efficiency. Or you could do some sort of like contesting for this, where you could have essentially, you could run the same computation through 2 different zkVMs, and then if one of them disagrees, essentially the rollup would freeze. Right, so you get a multi-proof system very easily. You're still running the get client or ret or zet or whichever client you're running through, right? And you sort of inherit a multi-prover system for free. Like that's one of the nice things of zkVMs, and that has to do with also the upgradability because you can just sort of swap out which zkVM you're using below it.
Yeah, definitely. And I really wish we had more time. I think this conversation could last like a few days even, but would love to continue this conversation with all of you in the future. Unfortunately, we are running out of time, but really appreciate all the insights that you guys made. David, on the security side, like we're seeing bugs present in both custom circuits and zkVMs, but zkVMs more so on the compiler side. Lumi, I really liked all of your comparisons and all of your analogies with assembly, with DOS. And Vanishree, you brought up some great points on upgradability, reusability, and how like different stages in project maturity have these different goals. And some may be more suitable for zkVMs, while others may be more suitable for custom circuits as well. And also Morgan brought up some really great points on the trade-offs between hand-rolling circuits and then the compiler-based approach. So really appreciate all of your perspectives that you all brought in today. Yeah, thank you so much for joining.
Thank you.
Cheers, thanks.
Yeah, thank you.